Okay. So, final test. You can hear me. You can see my screen, right?
Yes, at least me.
At least you. Okay. So before I begin, a short introduction and an apology. This is very strange for me because usually I do talks in front of an audience. I don't really like the online format because it has very little interactivity. And today is even more so because of the way that I present my screen, I can't really see any kind of responses from the BlueJeans platform. So I'm just looking at my screen, staring at my slides. However, if you do have questions, and I don't know what the mechanism is, I think there's a way to ask questions on the platform, or I will leave some time for questions at the end, and we'll see how we can do that. So
Yeah,
first of all,
we will have 5 minutes at the end. You can ask in Q&A or just in the chat because if the Q&A is too complex.
Great. So my name is Guy Barnhart Magen. I'm one of the members of the B-Sides Tel Aviv team, which I hope that everybody is familiar with. We have a yearly conference event in the summer during the Cyber Week events. And I'm also the lead on the B-Sides Tel Aviv Capture the Flag event, and I lead the CTF team for that as well. I'm a security researcher. I worked for a couple of different companies. I usually manage teams. I do little hands-on security relevant security research these days. And my main topics of interest is operating systems, cryptography, and machine learning in general. I've been talking on a lot of different topics around the world in many different conferences, and this is part of the way that I think of giving back to the community. But this is kind of a small echo chamber where we as security-minded people talk to other security-minded people, and we kind of share the same views, and we keep hearing about the same things, and we keep saying the same things to each other. And we're not really making a lot of a difference in the larger scope of things, at least not as much of a difference as most of us would have hoped for. And I think that today's topic is going to address exactly that. So a couple of weeks ago, I think it wasn't even 2 weeks ago, 12 to 14 days ago, more or less, the Prime Minister came out in one of the press conferences, the daily press conferences, with an announcement that Israel will now use one of the defense military intelligence technologies that we have to use cellular tracking in order to keep track of the general population, the citizens, to see who is a confirmed corona case and where were his locations done previously. So that was the announcement. The announcement was very strange at the time because nobody had exact information. The Shabak, the internal security service, was not really geared up to do that, and they kind of pushed back. Then everybody else pushed back. But the reality of the matter was that they made a decision at the government level that they need a way to track where corona carrying patients, people who were confirmed as corona carrying, where have they been for the past 14 days? Because the epidemiological investigation was very lacking in information. People really didn't remember where they were, and they didn't have a lot of hard data to go by. And the decision was made to use cellular tracking information so we can backtrack and rebuild their travel routes. So once we know that a person is now known confirmed corona carrier, and he's now a corona patient, we can use that technology in order to backtrack 14 days and say, okay, now we can trace where his cell phone has been for the past 14 days, and now we have a better a method of determining what exactly was his route. So obviously this has a lot of drawbacks, and I'll discuss and cover a couple of those drawbacks. And it also created a lot of turmoil because this is the first time that such an invasive technology was used here in Israel against the civilian population, and without a due process and without due consideration, and without even considering the alternatives to reach the same goal. So this isn't normal. The entire situation that we're at right now isn't normal. It's not normal to stay at home. It's not normal to have meetups over an online platform. And it's definitely not normal for the government to ask for your location for the past 14 days. On the other hand, there is a clear and present need for that information. We need to be able to determine if someone is carrying corona, where has he been for the past 14 days? If he has not been in isolation for the past 14 days, where were he? Was he going to the supermarket? Was she attending a class? Was he going to a cafe? Was she going to to the car mechanic to fix her car? All of that information is hugely important. And in times like this, the need of the state to know that information kind of trumps the need for privacy. At least that was the consideration that the government had and decided to move ahead with this technology and with this plan. So the basic premise, the basic requirement for the system is that we need to track locations of citizens. We need to track locations of citizens that we don't know that are carrying corona right now. So sometimes between now and in 14 days in the future, some random person X might be a corona patient. And if he is a corona patient, then we need the location history for that person. However, if we look right now where he was 14 days ago, we don't have that information. We need to carry and collect that information ahead of time. And this is very problematic. The second thing is that we need to think about this at scale. When we have 100 corona patients, this is something that an epidemiologist can sit down with those patients and collect the information and retrace the routes. If there are 500 corona patients, well, maybe you can sit more researchers and collect that information. If we have 15,000 corona patients, this is beyond the scope and beyond the scale of what we can actually do. So using technology to solve that problem is actually quite obvious. We know how to track locations, we know how to do this securely, we know how to do this at scale. The government kind of had issues there. So the easiest solution for most of us as security people and for most of the populace, for people who care about programming and very much care about civil rights, would be, just shout out and say, this is wrong, this is not the way to do it, but this is what the government decided, so we don't really have a lot to do about it. But this is not the only solution, and it's not even the easiest solution. Because if you have a little faith, Avi will excuse me for using that word, if you have a little faith that the government isn't basically evil, it's just an organization like many other organizations, and in many organizations, security people and security and privacy-minded people are not the majority, you can find a path that can help them to find out and to better understand what the issues are and how to solve those issues, because at the bottom line, we all want the same things. We want the system to work. We want to be able to collect location history from corona patients. We want to be able to contain this epidemic, but we also don't want to use too blunt of a hammer. We don't want to send everybody to isolation. We just want to send people who are suspected to have matches with corona patients in their locations to isolation, and not everybody in the near vicinity. My partner and I, Omri Segev Moyal and myself, were contacted because of previous work that we've done in this area to see if we can help the government, the Ministry of Health, to build a better architecture, an architecture that preserves the privacy and security of people using the application, but also to solve that problem at scale, because we are not planning for the use of 2,000 people installing the application. We need 2 million people installing the applications or more. And we need to be able to solve that problem at scale. The last caveat that I want to mention here is that there is an entire team in the Ministry of Health building this application. They are doing the development, they are doing QA. Our hats here was security and privacy, just to make sure that they are doing the right thing. And what I want to discuss today is how we help them to do the right thing with everyone. The three basic principles that we wanted to make sure are covered is to make sure that the users, us as citizens, retain the ability to make the choice. We need to be able to choose, do we want to share information or not? the current system that is being used by the Shabak cellular tracking technology doesn't ask you for permission for your location history. It directly accesses the cell phone provider's information and gets your cell phone location history from them. Your only option is to turn off your phone. So you don't have a choice to either participate or don't participate in it. And in democracy, a choice is a very important aspect. The second thing is that we want to make sure that this is a privacy-preserving architecture, meaning that information about you, about your location history, will not be shared with the government if you do not choose to do so, but also that if that information is further shared with other people, that your privacy will be protected as much as possible under the circumstances. And the last thing, we wanted that architecture to be secure, so it won't be able to be easily influenced by attackers, by malicious actors, or by other people against this system, against this scheme. If you haven't noticed, a lot of different Corona apps have been popping up in this space, doing different things, from trying to identify your symptoms as Corona patients, from trying to aggregate all of the news and information in one place. In other words, there's a lot of different applications. However, because the Ministry of Health is directly pushing this specific application, its reach and its importance, it's much higher than anyone else who's just trying to build an application for the greater good. A technical note about spatial data. So the basic thing that we're trying to do here is to collect location history from your phone and compare it with location history of other people who are confirmed Corona cases. And if there is a match, 2 days ago, both of you were in the supermarket at the same time, so you were both a temporal match, you were there at the same time, but both a spatial match, meaning that you were in the same area at the same time. That means that it is possible that you might have contacted that Corona patient and you might have been infected. Maybe. There's a big maybe on top of all of that. So the first part is easy. If we know where a Corona patient has been, at which places and which timestamps, we can check your device and see has your device been in the same places at the same time. But in order for the application to determine if you were at the same times at that Corona patient, we need to collect location history. And on our cellular devices, there are a lot of different ways to collect location history. The most obvious one is to use the GPS that all of our smartphones has. Most 99.999 whatever have that GPS location tracking enabled, and that means that it's available for the application when it wants to know and read its location, the current location at this current timestamp. GPS is rather accurate. It's not the most accurate. It's the most accurate that you have on your phone, but there are other methods as well. There's another way to determine your location through cellular triangulation. So when your phone is connecting to the different cells in the vicinity in your area, each cell tower also broadcasts its GPS location. So it's possible for your phone to connect to the different cell towers and say, okay, I can measure the distance between the device and that cell tower through the degradation of the signal over the air, the radio transmission, and I know the location of that cell tower, so I know my approximate distance from that cell tower. And if I have 3 different cell towers, then I can triangulate that information and get a very rough position without using GPS signals at all. Obviously, this is not very accurate because, one, it is based on the decay of radio signals, which a line of sight is good for, but also different buildings, different structures also kind of mess with the signal. So it's not very accurate, but it's still possible to get a very rough location. So if you wanted to know your position, roughly plus minus 500 meters, it's good enough for that. GPS is usually good enough for plus minus 10 meters to know your location. And again, if I want to know my distance or at least my proximity to a Corona patient, if I can say that I was in the same area with him, plus minus 10 meters, that's probably good enough to go into isolation, say I might contacted the Corona. If I have a 500-meter distance or a 1,500-meter distance, it might be a bit too much to say maybe I wasn't even in the same space at that corona patient at the same time. Two other aspects that are very useful for determining your location is Bluetooth signals and Wi-Fi. So I want to tackle Wi-Fi first. Wi-Fi, at least for some of the Wi-Fi broadcasters out there, sometimes they also include GPS data. So if you go by known public locations like next to a coffee shop or something like that, so they have a fixed address. And if you know the SSID for that specific Wi-Fi, that usually has a match where you get a rough coordinate location for anything else like a GPS or a cellular. But because the address of that business is known and it's fixed, then you know that you were right next to that business and not in the vicinity of that business. So Wi-Fi can be useful. Bluetooth might even be more useful than that, because if you can fix a Bluetooth beacon in space and say, I know that this specific Bluetooth beacon with this specific MAC address has this location, and you just connected to it or just scanned it and you were just next to it, that we know that your spatial relationship to that beacon was that you were in close proximity to that beacon. However, normally, you don't collect information about Bluetooth and Wi-Fi. And more than that, even for most cases, most Bluetooth and most Wi-Fi hotspots that you will go and scan don't include any kind of location information. So what do we even care about Wi-Fi? So this goes into a more stronger requirements that we want, is that we want to be able to differentiate in the same area, in the same location. We want to differentiate between two groups of people. And I'll give an example. Let's say that you work in one of the big high-rise towers in Tel Aviv. Let's say Alon Echad or Azrieli or something similar to that. One of the large multi-floored high-rise. From a GPS coordinate point of view, you are in the same coordinate. You are co-located in the same address. Most GPS systems are pretty good in determining your X and Y location, your longitude and latitude. They're not so good in determining your altitude. So differentiating between two people who are in the same building, but one is in floor 18 and the other is on floor 36, is a bit harder because they both share the same kind of GPS coordinate. They both share the same kind of cellular triangulation. However, if you keep track of what kind of Wi-Fi signals each device has seen, that means that you can differentiate who is on floor 36 and who is on floor 18. So collecting Bluetooth information and collecting Wi-Fi information is also beneficial to differentiate when you're trying to determine the location history of that corona patient or that suspected corona patient. Is useful to differentiate between those groups. So if I went to that building and the corona patient went to the same building and we were at the same building at the same time, we can say, but we weren't at the same location because we saw completely different Wi-Fi signals. And that means that if I was on floor 18 and the corona patient was on floor 36, then we can tell the entire floor of 36, please go into isolation, but the rest of the building should be fine. And this kind of granularity, this kind of fine control, not sending just random people into isolation just because they were in the general scope or the general area, is what we are looking for. So what do we want the application to do? What does the application actually do? We want to know if your device was next to any of the known locations of corona patients. But that is not enough because, as we said, the location data is very coarse. It's not very accurate. So what the application does is say, look, 10 days ago, you and corona patient number 417 were at the same supermarket at the same time. And we know that from your location data. However, maybe that's wrong. Maybe you were not at the supermarket. Maybe you were just at the coffee shop next door. So we want you to confirm that you actually were at that supermarket. If you confirm that this is actually a true match, this is not something that's determined by the algorithm, that you actually remember that you were at that location, then there's a very high probability that you might have been exposed to a corona patient. Right now, the application doesn't share that information. In a future version, it will be easier to just say, yes, I think that I was exposed to that corona patient. Please share my information. Right now, this doesn't happen. Everything happens on the device, and it's kept in the device, and there's no API, there's nothing that pulls information out of the device. In future versions of the applications, we want to be able to share that information, obviously, with very strict consent by the user. So, a flow of the application and what we help the Ministry of Health to achieve. So, the first part is that you install the application. The application is available both on Android and iOS. And once you install the application, it starts collecting information from that point in time forward. It doesn't read the Google APIs to know where have you been for the past 14 days. Because there's no API to do that. There are a couple of hacks that we're looking into. But the bottom line is that we don't have a way to do that reliably right now. So we need to first start collecting information, and that information will probably be useful on average in 7 to 14 days from now. So the application is running in the background, and it starts collecting information. Several times a day, usually about once every couple of hours, the Ministry of Health is updating a JSON file that's on an Azure Object Storage that contains the location history or the path for each one of the corona patients, those confirmed cases of corona patients. And the application takes the updated JSON file from the server. The JSON file is downloaded and is kept on the device. From the server to the device, and now the device is doing a computation of sorts. It's trying to match everything that's kept in the local SQLite database on the device, all of the location history that's kept on the device, with a downloaded JSON file that's also on the device, and trying to match those locations. If there's a match between you and the corona patient, and a match here meaning that you are in the same area, plus minus 500 meters, more or less, if you're in the same area, then a notification is being popped up to the user asking, is this a real match or is this a mistake? If this is a mistake, the alert would be hidden and you will not be notified again about this match. If this is true, the alert will be hidden and you won't be notified again about this match, but you will also be presented with a link to go to the Ministry of Health website to the self-isolation form where you can report that you had a contact with a confirmed patient. There's no data being forwarded from your device to the Ministry of Health. You don't even have to click that link. This is the same form that everybody can fill when they come from abroad or anything else. I did so myself when I returned from Europe. And the application isn't sending any kind of information to any kind of server outside of the device. It just doesn't exist. The bottom line is that in both situations, if you agree that there's a match and if you disagree that there's a match, everything is being kept on the device, and the device doesn't output any kind of information. Basically, what the application is helping to do is to help you as the user of the application to determine if when you went about your business, whenever we are allowed to go outside of home to do our business, maybe you crossed paths with a confirmed corona patient. So you want to know, and you want to go into isolation to protect your family, to protect your loved ones. This is the first thing. The second thing is, and this is the voluntary part, if you actually have corona and the Ministry of Health is conducting an epidemiological investigation, try to determine where have you been, you don't have to remember where have you been for the past 14 days, because now the application can share it will be able to share that information in the future with those investigators to have a very exact way to determine where your device has been and where you have been based on the same information. Once they get that information, they push that into the JSON, which goes on the Azure Object Storage, and now the rest of the applications on all of the devices can pull that new information and calculate new matches if they exist. Hopefully, none of us will have to have a notification that says we were exposed to corona, but this is something that we need to think about as we are going to see more and more corona patients in the coming weeks. We're going to scale from hundreds to thousands to tens of thousands at least, if not more than that. on my own personal estimate. So to wrap this up, what did we try to achieve? We wanted for the application to be useful, it had to have wide adoption. For us as security persons, we wanted to have a private architecture by design. We didn't want the government to have any kind of information that people did not consent to actually give them. And we wanted the application to be secure. We didn't want to have people messing with it, malicious actors pulling information, influencing, causing panics. That's what we wanted to do. The way that we did this, that we pushed really, really, really hard to tell them that this application needs to be open source. We wanted that application to be open source because, one, we are not the best security people around. The best security people around is having a lot of security people around. Different people have different viewpoints, different experiences, and different ways to do things. And as we have more eyeballs, that means we have a better security product. So going open source, and they chose the MIT license, meaning that anybody can do anything with it, more or less, means that each and every one of the security community can go on GitHub, look at the code, file issues, file pull requests, and improve the security of the product, more than just having a static security review once a couple of versions. The second thing is that we wanted to make sure, and we did make sure, that no information is being sent to the Ministry of Health. The only thing that the application is doing is pulling a JSON file from the Ministry of Health and doing the computation on the device itself. In a future version, it might be able to share information, but for that, we required and we said in no uncertain terms that user consent must be provided in order to send any kind of information from the device. And because the application is open source, you will be able to validate that this is actually the case. The last thing is security architecture. There's no central database. There's no big, Redis caching in the backend. There's no MongoDB that you can hack. It's a JSON file on object storage that everybody is accessing and pulling to their own devices. There's no API to communicate. There's nothing complex going on in the backend. You can go look at the code. It's actually relatively simple. We did ask and got that everything will be over TLS because, we're paranoid. But the next version will have the signing of the JSON, etc. We're improving the security of the scheme relatively fast. And we want it to be as secure as we can, but we also wanted the application to be out there as soon as we can because we need to collect information first and make the security posture of that application later, to make the security posture better later. The last thing that I want to say about this is that the people there pulled this application together in something like a week and a half. So if you think this was like ready 30 days ago and they just polished it, and no, this was like something completely new for a government agency to pull something like this out of the thin air, to get collaboration from the community, to call on security researchers to come and take a look, to open this as open source. We plan to open this on open source next week, but we already opened it which day is it? On Sunday night, because we got such positive comments from the community. This is something, at least in my experience, that was unheard of. And this means that you can actually do great things. You can do the right things when you have the ear of the people in the government. Instead of going against them and telling what they cannot do, we went with them and told them how they should do. And I think that the bottom line is that we were able to do an application that does a very difficult thing from a privacy perspective in a secure, in a private way, and in the way that everybody can feel comfortable with it. And if they don't feel comfortable with it, it's not mandatory. User choice is still part of the flow. You need to choose to install that application. So I just have a minute or two to wrap things up. So I do want to say that a lot of people worked on it, both in the Ministry of Health, a lot of volunteers, people who did the development, who did the Q&A, our team who did the security, but also a lot of people in the security community who took part. We have, I think the last time I checked, 80-something issues opened Translation into Arabic and French and Russian already added to the application. We're adding new features, solving bugs, and everything that happens like in a whirlwind since Sunday night. I was up until 2:30 in the morning answering questions on Twitter on Sunday. So there was a lot of interest from the community. And I think the bottom line is that we passed, in like 24 hours, we passed more than 500,000 installs on Android alone. Means that people trust the security community enough. Say, okay, this is scary, but I trust those people that they actually checked it. So I will install this application. And that means that it's better for all of us, for all of the citizens here, that we have a better reach for this application. I do want to say that it wouldn't have been possible without the right people at the Ministry of Health. They really were open to doing things differently. They were open to listening, and they were open to open sourcing it as a way to reach the goals that they set that they wanted to reach. And I think that this was a great success for everyone. So my last two slides, if you want access to the GitHub, you can take a screenshot of this QR code. You can look at this URL. It's also on Twitter everywhere, more or less. You can contact me and I'll hook you up. Or I will share these slides later and you can have the URL there as well. And with that, I'd like to say thank you and thank everybody who was involved, the security team, the QA team, the development team, the Ministry of Health team. I think that we were able to pull something really great in a really, really short amount of time. Thank you.
Thank you, Guy. We really appreciate you joining this meetup in really short notice. So thank you very much. And I see we have a question. We have actually two questions. First question, do you have a plan for using Bluetooth or Wi-Fi data in a privacy protecting way? Not sure I get it, but maybe you?
I do. Let me answer that and then I'll answer the second one. So right now the application is collecting SSID labels and MAC addresses. But the way that we designed it is that we're not collecting the labels themselves, we're actually collecting the hashes of the SSID labels and the MAC addresses. The reason that we collect that information is that we want to make sure that if both two different people, let's say the corona patient and some random people were in the same geographical location, but they didn't see the same kind of Wi-Fi SSIDs at the same time, it might mean that they occupy the same building but not the same floor, to use the same example I gave earlier. So this might help the corona investigator to say, okay, so we don't have to quarantine everybody who was in that building. We can limit the scope to just everybody who was on that specific floor. So to answer the question, yes, we do plan to use that. The current algorithm does not take that into account, but we are collecting that information. So the next version or something like that will be able to take that into the matching algorithm.
Okay, I see.
Second question.
Yeah, we have a few more. Do you want to read? It's on the chat. So does the app needs to have location services on all times? On at all times. So.
Yes and no. The application polls, I think every couple of minutes, like every 10 minutes or something like that, it takes a sample. So it needs to have location services enabled on the phone, but it's not taking location samples continuously. So I think I need to read the code to see the parameter, but basically something like every 10 minutes, it writes a new line to the database, to the SQLite, the local database that says timestamp, SSIDs, GPS coordinates, something like this.
Okay. One more. Nina is asking, wow, unbelievable. How does the JSON being downloaded on the user machine prevent it from being corrupted?
Well, right now, it doesn't prevent it from being corrupted. It can be corrupted. So let's break it into two different use cases. The first one, some error has occurred and the JSON is corrupted. Hopefully, the application will pick it up and say the error has occurred and try to re-download it again. Second use case is somebody is corrupting it on purpose or somebody is modifying it maliciously on purpose. So this is a different use case. One, I think the next version, the one after that, will introduce JWT to sign the JSON. Right now, this is a functionality that we asked for but hasn't been implemented yet.
Okay, and I think we have time to two more questions. Okay, the last one, the I think relevant one. Guy, do you install the app on your mobile phone?
I did.
You did. Okay, so
I also
yeah,
recommended it to my family, and I'd even say more than that some members of my family they sent me the link that there's a new application. You have to be very worried. This is a ploy by the government to get your location history, etc. And I told them, look at the same article. You'll see my name in that article saying that I said that it's okay to install it. And said, oh, really? And I said, yes, really, it's in Haaretz. You can see my name there, and I say it's okay.
perfect. So now that's reassuring. I'll install it as well after the meetup. Thank you very much, Guy.
You don't have to trust me. You can look at the code yourself. But if you do want to trust me, that's fine.
I know. I have friends that look at it. So I'm waiting for their response. But now I feel better.